Well, hello everybody. Let me show you what we got going on today. I'm going to jump back and forth on screens today. I'm going to close out the PowerPoint here in just a minute and show you a graphing calculator to kind of lead into what I'm going to do today. But if I were there, I would answer any questions over finding inverses. We should be pretty good with that since I added in an extra day for it. We are going to bypass the homework quiz today. There is a possibility for a quiz at the end of the period. We talked about that one. But what I need to do today is begin working with you on what we call the square root functions, what they look like, their domain, and their range. But before I do that, here's where I want to start. I want to take you back to something that we had done before. We had graph functions like this before. These happen to be parabolas. But I want to take you for a trip down memory lane real fast. Let me graph the function y equal x squared. You should remember this from a couple of chapters ago. Now here's what I need to remind you. At one time, guys, we were really good at this. I need to make sure that you remember what that minus 2 does to the graph. Think about that for a second, see if you remember, and then I'm going to hit graph and watch what happens. The minus 2 inside the parenthesis, notice that it happened to move the graph to the right 2 units. So remember, if something's in a parenthesis, it moves it left or right. And it's opposite of what you think. So like if I had a plus 3 in there, it's going to leave this original graph right here, and it's going to take it and move it 3 units to the left. So let's check that out real fast. So notice how it moved it 3 units to the left. See if this sounds familiar also. If I just have a number at the end, what that does, it moves the graph up or down. And in this case, notice that it moved it up 5 units. That plus 5 moved it up. If I went ahead and did a minus 7, you should have a good guess what that's going to do. It's going to take this graph right here, and instead of being up at 5, it's going to be down 7. Now see if you remember what this does. I'm going to put 2 moves together here. I'm going to go something like, I'm going to go x plus 3 inside the parentheses, and then I'm going to go minus 4. Can you remember what that's going to do? It's going to move the parabola 3 units to the left, and then it's going to move it down 4. So it's going to take this vertex and move it to the left 3 and down 4. We're going to use that same concept today. I'm going to throw one more at you here. If I went x minus 5 quantity squared plus 3, you should know what that vertex is going to do. Instead of being here at 0, 0, it's going to move it to the right 5 units and then up 3. So let's check it out. Looks like it moved it over 5 and up 3. We're not going to worry about it much today, but remember when I put a number in front of there, remember what it did to the graph? It either compressed it or stretched it. If I put a big number in front of there, it makes the graph skinnier. So check that out. If I put a small number in front of there, like maybe a 0.2, it makes the graph quite a bit wider. All of those rules are going to hold the same today. But instead of working with parabolas, what I'm going to do with you today is work with square root functions. So that's the main graph that we're going to look at today, the square root function. What the square root function does, it starts at 0, 0, and then curves to the right. You can graph that in your graphing calculator if you want. Here in a little bit we will, just so that you know where to type it in at and everything. But some things that I know, my domain is going to start at 0 and go to the right forever. So 0 to infinity. My range, the y values, is going to start at 0 and go up forever. And now all the rules that we just talked about are the same. Look at your partner next to you real fast. Tell them what you think that minus 2 underneath the radical is going to do. And hopefully you said 2 to the right. Notice that minus 2 in there slid it over 2 units. Guess what a plus 2 is going to do? Going to slide it to the left 2 units. So the same rules of the parabola apply. If I put a plus 3 out here, I think you know what it's going to do. It's going to move it 2 to the left and then up 3. Notice that it just starts right here. That's its starting point, and then it goes to the right forever. Those are some things I'm going to talk about here in a little bit. So let me close this out. Let me flip my computer around real fast to get this thing set up so where I can talk to you, and then we're going to start going over your class notes now. So if you will, look over on your notes there, and then let's start talking about these. Let me get through a couple of these slides here. Let me tell this thing that I need ink. So here goes. If you would like, grab your graphing calculator, and you can graph the square root of x. I'm hoping that I had a few minutes last class and we already talked about the graphing of it. So you'll have to hit second, go down and find your square root, and then these calculators should put a parenthesis there for you. So that part's going to take care of itself. But here's some things about the square root. Its domain is going to be 0 to infinity. In this case, because it starts there at 0, its range is going to be also 0 to infinity. I'm not going to worry about the end behavior much. We did this just last chapter. Remember, this says as x approaches infinity, as x goes to the right, my graph's going to keep going up forever. As x approaches 0, so as it's going this way, I'm going to approach 0. Like I said, I'm not going to worry about that part of it. Okay? So if you will, flip over or look down at that next. This is the stuff that I talked to you about, the parabolas. If it's underneath the radical, let me get some ink again, dang it. If it's underneath the radical, okay, let's try this again. If it's underneath the radical, it's going to move it left or right, and it's opposite of what you think. And then the k out there is going to move it up or down. The a out here is either going to make it grow faster or not as fast. We're not going to worry about this a lot today. We're going to graph these by plotting points, so it'll take care of itself. We're not going to worry about this part at all. We did before, that was that stretch vertically or compress. So here goes. We're going to try to do a lot of these without our graphing calculator. So look at your number 1. It says identify the domain and the range of the square root function, write the translation, identify the domain and the range, and then begin by making a simple sketch. So here's what I'd like for you to do on number 1. If you will, make a sketch right there, and then think for just a second. What's that plus 4 going to do? It should move it 4 units to the left. So I'm going to have a square root graph that's going to look like this. It's been moved over 4 units to the left. So in words, I'm just going to say 4 units left. This will be new to you. Last time when we did parabolas, I made you write out a statement that said this: the graph of f of x equal x squared has been moved or translated. I'm going to give you the shortcut to that today. You're going to use a capital T. T for translation. It's been moved 4 units to the left, so I'm going to show a -4, comma, and I'm going to put a 0 here. because we didn't move it up any. So this means 4 units left. This means up none. Now we can rock and roll the domain. My domain of this is from -4 to infinity. The range of this thing, in this case, is 0 to infinity. And then we're done. I could let you use the graphing calculator, but it's faster without it. So number 2, look at your square root of x minus 3. That minus 3 is under the radical. So predict what that's going to do. It's going to move 3 units to the right. So a simple sketch, 1, 2, 3, dot right there, going to the right. Hey, notice I don't care how accurate your graph is right now. It's just helping us name the domain and the range. Under translation, capital T, it went 3 units to the right, so I got 3, comma. There's no number out here to move it up or down, so I'm going to put a 0. We'll change that here in a little bit. On number 3 and number 4, we'll change that. For my domain then, guys, it's going to be 3 to infinity. My range is going to be 0 to infinity. Notice how this number helps deal with the domain. Notice how this number helps deal with the range. So that's all we're doing on these so far. Look at your number 3. I'm hoping that you can look at that and know in words what it's going to do. It's going to move it 2 units to the right, and then it's going to move it 5 units up. Underneath the radical, opposite of what you think, outside of here, what you see is what you get. In terms of a translation, I'm going to use a capital T, and then just list it. +2, because I went 2 to the right, and it's going up 5. So 2, comma 5. This tells the world 2 units to the right and 5 up. My rough sketch of it, 2 units to the right, 5 up. So here's my starting point, the 0.25. What's that make your domain? I'm starting at 2, and I'm going to infinity. My range, it's already up 5 units, so I'm starting at 5, and I'm going to infinity. And then we got it. If I was there, I'd have you try number 6 on your own, but since I'm not there, here goes. This thing is going to go 6 units left and down 2. As a translation, -6, comma, -2. 6 left, 2 down. As a rough sketch, 6 units left, 2 units down. So here's my starting point, -6, -2. That graph should help you get your domain. My domain is going to start at -6, and it's going to the right. Notice that number right there. My range is already down 2 units, and it's going up. So there's the first piece of it, guys. Now, if I was there, we would do this next part of it in your graphing calculator. But since we're not, we're going to try to do this in our heads. And I know you say, oh no. So here goes. Look at number 5. I would like to graph this thing, and I want it to be pretty accurate. Here's our main thing that I want to do. I need you to remember the numbers 0, 1, 4, 9. 0, 1, 4, 9. Those are numbers that I know the square root of. So those are the numbers that we want. So to graph this thing, here's what I'm going to do. If you will, set up a little T-chart. Do not put 0, 1, 4, and 9 in your x-coordinate. That's not what I want here. Think about this. I want you to turn x minus 2. Turn that into a 0 for me. So what minus 2 gives you 0? Well, 2. Why did I want you to start with the 2? Check this out. 2 minus 2 is 0. The square root of 0 is 0. 0 plus 3 is 3. There's my starting point. You should also know that because we know this is going to go 2 units to the right, up 3. So now next, pick on the 1. Something minus 2 is 1. What is that? I'm hoping that you said 3. 3 minus 2 is 1. The square root of 1 is 1. 1 plus 3 is 4. I'm hoping that you can do this without your calculator. Remember, soon, guys, we take your calculator completely away from you. Now turn it into a 4. Something minus 2 is 4. What's that something? It's a 6. Because 6 minus 2 is 4. Why did I want that? 6 minus 2 is the square root of 4. Well, what's the square root of 4? 2. 2 plus 3 is 5. And then turn it into a 9. So to turn this into a 9, looks like I better use an 11. And then here goes. 11 minus 2 is 9. But the square root of 9 is 3. 3 plus 3 is 6. Now let's graph this thing. Over 2 up 3. There's my starting dot. Over 3 up 4. Over 6 up 5. And over 11 up 6. So I'm somewhere out there a little bit. But here's my graph. Now I'm ready to do the domain and range easily. My domain starting at 2, going to the right forever. It went up 3 units. So my range is 3 to infinity. So think about it. 2 right, 3 left, or 2 right, 3 up. So there's that first dot, and then we had to get a few more. If you feel good using the graphing calculator in the table, you could check that. But I want you to try to do this in your head. Here's my number 6. Remember the magic numbers, 0, 1, 4, 9. So we're going to set up a t-chart. Be careful with this negative right there, though. What turns x plus 2 into 0? So something plus 2 is 0. Also think about this. Plus 2 is going to move it 2 units to the left. Now in your heads, here goes. Negative 2 plus 2 is 0. The square root of 0 is 0. 0 plus 1 is 1. Now turn it into a 1. What plus 2 is a 1? Well, that's going to be a negative 1. Then here goes. Negative 1 plus 2 is 1. The square root of 1 is 1, but I got a negative, so that's really a negative 1. Plus 1 is 0. Now let's pick on a 4. Something plus 2 is 4. What's that something? Well, it's a 2. So now here goes. Let's go get the number. 2 plus 2 is 4. So I got the square root of 4 plus 1. Really, I got the negative square root of 4 plus 1. So I got negative 2 plus 1, which is negative 1. And last but not least, let's pick on 9. Something plus 2 is 9. What's that something? A 7. 7 plus 2 is 9. Now let's go get this number. 7 plus 2 is 9, so I got the opposite of the square root of 9 plus 1. The square root of 9 is 3, so I got negative 3 plus 1 is going to be negative 2. Okay, so now let's graph this. Negative 2, 1 is my starting point. Negative 1, 0. 2, negative 1. 7, negative 2. Hey, so notice this thing, guys. It's opening down. It's opening down. that negative sign flips it around, makes it open down. Hey, domain and range though, we can still get that. My x value starting at -2, but it's going to the right. My range started up here at 1, but it went down. So my range is -infinity to 1. Bracket on the 1, parenthesis on the infinity. I'm going to do number 7 real fast, and I'll probably move on because I notice this video is getting a little longer. So here's my number 7. Let's set up a little t-chart, x, y. And remember our numbers, 0, 1, 2, 4. Let me say that again. 0, 1, 4, 9. Must be late on a Sunday night. I want to turn x plus 3 into 0. Something plus 3 is 0. What's that something? -3. -3 plus 3 is 0. The square root of 0 is 0. -2 times 0 minus 1 is -1. Which makes sense. 3 to the left, 1 down. Turn this into a 1. Something plus 3 is 1. What's that something? -2. -2 plus 3 is 1. The square root of 1 is 1. So I've got -2 times 1 minus 1. So -2 minus 1 is -3. Now let's turn it into a 4. Something plus 3 is 4. What's that something? A 1. 1 plus 3 is 4, but the square root of 4 is 2. So I'm going to have -2 times 2 minus 1 is going to be -5. And then now let's pick on a 9. Something plus 3 is 9. What's that something? 6. Well, 6 plus 3 is 9. The square root of 9 is 3. So I've got -2 times 3 minus 1. -2 times 3 is -6. Minus 1 more is -7. And then we got enough to graph it. -3, -1. -2, -3. 1, -5. And 6, -7. So another one that's opening down. My domain, -3 to infinity. My range, the biggest number I'm using is -1. So -infinity to -1. So there goes. Those are square root functions. So remember 0, 1, 4, 9. Okay. Hang on, and I just got a couple more. Well, the inverses. So I'm not going to worry about this one. I'm hoping in the T-chart you would have been able to pick this. To get a 0, 1, 4, 9, you would have used a 1 because 1 minus 1 is 0. You would have used a 2 because 2 minus 1 is 1. You would have used a 5 because 5 minus 1 is 4. And then you would have used a 10 because 10 minus 1 is 9, of course. So here goes. Hey, now, if you would, look at the graphs that we did. Do the graphs of the square root functions all pass the HLT, the horizontal line test, just like what we had last time? The answer there, of course, is yes. What does that mean for you guys? Could we find the inverse? Yes. So we're going to do exactly what we did last time on finding the inverse. The steps aren't the same. That's why the only thing I covered with you last time was the inverses, because I knew this was coming. So we're going to follow these same steps. I asked you, do they sound familiar? They should. They're the exact same steps that we did last time. They're the exact same steps on that little quarter or third sheet of paper that I gave you. So have that out if you would. If not, I left some extra for my sub. So here goes. If you will, look at your number 9. we're going to follow those steps of finding the inverse. So if you look at your sheet of paper, remember it says, graph or draw a sketch of the given problem, then ask yourself, does it pass the HLT? Well, something I know, guys, this is going to go 1 unit to the left and look like that. So that definitely passes the HLT. All of our square root graphs will, by the way. Then it says replace f of x with y. Follow all of these steps, because usually on a test or quiz I give something for each step. So here goes. Step number 1, y equal the square root of x plus 1. Step 2 says switch the x and the y. So I now have x equal the square root of y plus 1. Then it says solve for y. Here's how we solve for y. To get rid of a squared, I'm going to square both sides. So if I square both sides, on the left-hand side I've got x squared. On the right-hand side I've got y plus 1. The squared and the square root cancel each other out. I'm going to get y by itself by subtracting 1 from both sides. And then now I'm going to label it correctly. So I'm going to say f prime, I'm going to say f negative 1 of x is x squared minus 1. All of these steps is your answer. That's the inverse. So those are our steps. So it shouldn't be too hard. Here goes my number 10. F of x equals the square root of x plus minus 4. I'm going to first say y equal the square root of x minus 4. I'm going to switch the x and the y. X equal the square root of y minus 4. And then I'm going to square both sides. So on the left-hand side here I got x squared. On the right-hand side I've got y minus 4. Now let's get y all by itself. So I'm going to have to add 4, so I got x squared plus 4 equal y. Now to correctly label it, f negative 1 of x, which stands for the inverse of course, is x squared plus 4. So there's the inverse, there's the steps. So don't shortcut the steps. Here's my number 11. Same steps, so let me say y equal the square root of 2x minus 4. Let's switch the x and the y. So I got x equal the square root of 2y minus 4. I'm now going to square both sides. So on the left-hand side, I've got x squared. On the right-hand side, I've got 2y minus 4. I need to solve this thing for y, so let's add 4 to both sides. So I've got x squared plus 4 is 2y. And then to solve for y, let's divide each thing by 2. So that's gone. My final answer, f negative 1 of x is x squared over 2, or you could call it 1/2 x squared, plus 4 divided by 2 is 2. So there we got it. Now number 12 is just a little bit different. It's got a little twist to it. But the steps are the same, of course. So here goes. I'm going to call this y equal the square root of x plus 3. I'm going to switch the x and the y. So I got the square root of y. Hey, but notice this time that plus 3 is outside the radical. It's outside the radical. Here's what we got to do. I got to subtract 3 from both sides first. What we have been doing is squaring both sides, but that's not going to help us. Now I'm going to have to square both sides. When I do that, guys, I have to do this on the left-hand side. I got to write that out 2 times. The right-hand side is just plain old y. Now let's FOIL. So I got x squared minus 3x minus 3x plus 9 equal y. Combine like terms, so I'm going to get f negative 1 of x is, now when I combine like terms, I got x squared minus 6x plus 9. The trick on that one is, notice this plus 3, it was not under the radical. Over here, it was. Let me also show you this. I'm going to erase part of what I have right here. I'm going to erase from here down for a second, just to show you something. If you would try to square both sides, I'm just going to show you this one so you'll see why we can't do it. Let's say you just wanted to square both sides. Check out what you would have to have. Over here you got an x squared. On this side you would write it out 2 times. Watch how ugly this gets. Square root of y times square root of y is y. But I have 3 square root of y plus another 3 square root of y plus 9. You can't solve that for y. So that's why I got to get the radical isolated. I got to get the radical all by itself. I'm going to hit number 14 with you, which is almost the same kind of problem, and then I'm going to turn you loose on your assignment. So I'm going to bypass number 13 because it's another easy one. But let me show you number 14. Here goes the steps on your note card. I'm going to call this y equal the square root of x plus 3. Notice that minus 4 is on the outside. I'm going to switch the x and the y. So I have x equals the square root of y plus 3 minus 4. I got to get the radical all by itself. So I'm going to add 4 over here. So on this side, I just got the square root of y plus 3. Notice I have the radical all by itself. That's what we got to do. Now when I square both sides, the right-hand side turns out pretty nice. It's just y plus 3. The left-hand side, though, I need to write that out 2 times unless you've gotten pretty good with the FOIL shortcut and FOIL. So I'm going to get x squared plus 4x plus another 4x plus 16. Get y by itself by subtracting 3. So now I've got x squared plus 8x plus 13 equal y. Now let's bring it home. Ending answer. F negative 1 of x is x squared plus 8x plus 13. So there we go. That's how you find the inverses. While I'm here, I'm just going to fly through number 13. Just for that little bit of practice, but I want to get that harder one out of the way first. So same steps on number 13. Switch the x and the y. So y equal the opposite of the square root of 2x. Switch the x and y, so I got x equal the opposite of square root of 2y. I know I said switch x and y twice instead of rewrite it. Hey, now I'm going to square both sides. Well, when I square this side, I got x squared. When I square this side, a negative and a negative make a positive. The radical goes away, so I'm just going to have 2y. Divide both sides by 2. So I've got x squared over 2, or 1/2 x squared, whichever way you like best, equal y. Ending answer, f negative 1 of x is 1/2 x squared. So that's our lesson over square root functions. Looking at my video, it looks like I yacked for about 35 minutes. That's going to give you not quite an hour to work on your assignment, about 55 minutes. So good luck on your assignment. Come in if you have any problems, but work together and see what kind of damage you can do. Good luck. Have a good Easter.